are all well. Today we shall learn about atomic size and atomic radius. So let's start. Atomic size, defined as distance from the center of nucleus to the outermost electron. Radius can be of two types. We can measure radius when it is spherical, but in case of wave there are two types of radius such that. Okay, so let's learn about atomic radius. Okay, there are four types of atomic radius: covalent radius, metallic radius, ionic radius, and Vanderwaal radius. At first we learn about covalent radius. Covalent molecule can be of two types: homodiatomic and heterodiatomic. In case of homodiatomic molecule or A2 type, we draw such type of picture. Now the distance between these two atoms from the center is d. Let's take is as d. So the radius of A will be d by 2. In case of heteroatomic, there are two types of molecule, AB type and AC type. Okay, AB type is such that where we cannot consider electronegative difference, and AC type is such that where considerable electronegative difference is present. Okay, so let's see. In case of AB type, where we do not consider the electronegative difference, so let's take an example. Here we take this pH. So the distance between the center of these two atoms is d, and the radius of our pH equal to d by 2. Now here we came to AC type. In case of AC type, we can consider the electronegative difference, and here we take the example of HF. Electronegativity of H is 2.1 and electronegativity of fluorine is 4.0. So electronegative difference is clearly noticeable. Okay, and the radius of AC type will be d equal to R of H plus R of F minus 0.09 mod of electronegativity of hydrogen minus electronegativity of fluorine. Okay, now our next topic is metallic radius. Metallic radius is calculated only for metals. Type of packing do not affect metallic radius. Okay, so here we take two atoms, and the distance between the center of these two atoms is d, and the R metallic equal to d by 2. Okay, our next is Vanderwaal radius. It is the half of the internuclear distance between two non-bonded atoms. Okay, and this is the structure of Vanderwaal radius. One thing you have to remember, that it can be calculated only for gaseous atoms, and since the force of attraction between the gaseous atom is very low, so they remain from one another and the radius also become high. Okay, next is ionic radius. It is measured for ions. Now we write this two ions, this is cation and this is anion. So the mu or radius will be R plus R minus. Always remember one thing, radius of cation will always be lesser than parent atom, and radius of anion will be higher than parent atom. Okay, also size decreases from parent atom to cation and size increases from parent atom to anion. So the order of ionic radius will be A minus greater than A plus. Okay. So lastly, let's see the conclusion. Okay. The metallic radius is half of the experimentally determined distance between the nucleus of nearest neighbors in the solid. Okay. The covalent radius of a non-metallic element is half of the experimentally determined distance between the nuclei of nearest neighbors. And the ionic radius of an element is related to the distance between the nuclei of neighboring cation and anions. Here we can see that ionic radius of O2 minus is 1.40 angstrom. So this is all about today's lecture. I think you understand this video. Thank you, and if you like this video then please subscribe the channel. Okay, thank you.